morning, everyone. I'm Autel. I'm the Group Director for Commercial UAV Expo. I'm thrilled to welcome you here to the Beyond the Cage outdoor drone demonstration. Thank you so much for coming. You're in for a treat. The Sundance Media Group is second to none when it comes to organizing demonstrations like these. Jennifer Pigeon and Douglas Spotted Eagle are amazing partners and have worked hand in hand with our vendors to create scenarios that showcase various solutions. I'd also like to thank our participating vendors today: Adorama Business Solutions, AEE, Autel Robotics, Commaris, Doosan, Skydio, and Skyfront. As you'll soon see, there's nothing like witnessing these systems in action. You can learn more at their tents during the break and visit their booths back at the show. The exhibit floor opens at 6:30 tonight. You were given a Beyond the Cage bingo card when you arrived. To fill out your bingo card, speak with vendors during the break to get the answers. The first person to fill out the card correctly will win a $150 Visa card, and you can visit the SMG tent to check your answers. And you can also use it as a fan. Help yourselves to water and refreshments at any time. And now I'll turn it over to Douglas Spotted Eagle to get things underway. Thank you.
Good morning, everyone. We've got some lobby. Hey, good to see you. Nice to see you, man. All right, well, welcome to the Henderson Equestrian Park and the ComUAV live UAV demo. This is our, I think, 4th year doing this. We're really excited to have you here. There's a few things that we want to talk to you about, of course, safety related. First of all, keep your hands and arms, legs, and head inside the window at all times to prevent any injuries. And I joke about that, but I'm halfway serious. If we happen to have an unfortunate event where the aircraft decides to take off on its own and toward the audience, what we'd like you to do is just simply place your hands over the back of your head and duck down just like you would do in a seat, in an airplane seat. Please do not get up off the bleachers and attempt to move. Chances are you're going to find yourself spaghettied up with the bleacher seats, and we're going to have an injury. We'd like to avoid that. So stay in place, hands behind your head, and just duck down. That's all you'll need to do. There should be at no time any aircraft anywhere in this area. All of our operations are going to take place beyond this concrete berm that you see right here in front of us. So all of the operations will be happening off to the west, to the north, and slightly to the east. So those are the most important safety factors that you need to remember. So please do not cross the barrier at any time. We will have the aircraft launch on the pads that you see behind me here. So they're fairly close in launch and land. You are welcome to take pictures and video of anything at any time that you wish. So please keep your cameras ready if you're looking to catch some fun. So far, with the exception of a parachute manufacturer 2 years ago, we have not had any spectacles or exciting things for you to see outside of the excitement of seeing the drones fly. So that's the goal here, is to keep everybody safe, keep the aircraft out of your way, keep you out of the aircraft way. A couple of other things operationally. There are porta potties and bathrooms up to the west side. So over where you can see all the trees, that's where all the water on the property is. That's where the bathrooms are located. So you'll be able to go down, and there's both porta potties and a fixed toilet right over here. So just if you look off to your left side behind you, you'll be able to find those without any problems. We're going to have vendors flying their drones for 20 minutes. You will see a combination of audio and video. Anything that is video related coming from the aircraft, you'll see up here on the screen, just where you can see Skyfront and their slide already prepped up. We will be operationally functioning at the accident scene that you see here in front of you. You will also see BRINC demonstrating their drone and its capabilities on this little house here. I think that for the most part, that wraps us up for safety and what you're going to see. There are a couple of things I failed to mention. You are not visual observers. You are not part of our crew. Drones will not be flying over. And a couple of you are laughing because 2 years ago we didn't have somebody that deputized the audience. That's not legal. So you are not part of the crew. And drones will not be flying over top of you. But if you happen to see something, let us know. maybe your eyes, I mean, collectively, we got 300 eyes here, 600 eyes here, I guess, that might see something that we miss. So feel free to let one of us know, one of us that in the safety vests and so forth, let us know if you happen to catch anything. Last but not least, looks like we've got a speaker coming up for me, Rowan. There we go, thank you. Last but not least, folks, if you're not used to the high Sonoran Desert, that's where you are. And whether you know it or not, you will dehydrate rapidly in this environment. Please drink a bottle of water per hour that you are out here. We have thousands of bottles of water for you. Please take advantage of that. Drink the water so that you do not dehydrate. We did have a couple of instances of dehydration yesterday during the demo rehearsals. So please, let's avoid that. You want to enjoy the show for the next 2 days. If you dehydrate today, tomorrow you will be horribly miserable.
Good morning, everybody. My name is Troy Messler, and I'm the CEO of Skyfront. And what we build are really long endurance multi-rotor drones. These are hybrid electric drones. If you look at the aircraft right there, you can see it's got gas tanks on the side of it. And we basically convert gasoline into electricity in flight. Next slide. I'm going to be giving you guys a demonstration of the perimeter UAS. That's what the drone is called. It is the longest flying drone in the world. Back in February, we actually set the world record for flight time. We flew the thing for 13 hours. It took off before sunrise and it touched down after sunset. That's not what we sell. We do not sell a drone that flies for 13 hours, but the drone as is with an external fuel tank did fly for that long. Next slide. The base drone flies for about 5 hours and has a payload capacity of about 17 pounds, which it can carry for about an hour. The maximum takeoff weight is about 51 pounds or 23 kilograms. And it is electronically fuel injected and extremely easy to operate, as I'll demonstrate in a couple of seconds. Next slide. For this particular demo, we're going to be carrying the YellowScan LiDAR. It's a new product by YellowScan called the Explorer. It's about 2.6 kilograms or about 7 pounds. And it has a range of about 600 meters, and you can take off and fly this thing at about 300 meters, which makes it ideal for carrying on both UAVs and manned aircraft. So without further ado, we're going to play a video, and then I'm going to get this thing fired up, and we're going to begin the mission. Okay, I'm going to be arming the drone in a second, and it's going to take about 60 seconds to warm up, and after that, I'm going to take off and begin the mission. All right, so we're beginning the mission right now. We're flying at about 60 meters above ground level. The LiDAR is acquiring data, and we're flying at about 8 meters a second forward speed. We're just going to do a quick lawnmower power lawnmower pattern mission over the desert here, and then we're going to return and land the vehicle.
As fun as it may seem, these LiDAR missions are rather boring.
Yeah, I was going to say, not much excitement.
Once you push, go to mission mode, it just goes.
It goes, right. Yeah.
Which is great.
Yeah.
I would describe flying this as like flying a bus.
Right.
It's a good thing.
Yeah.
So one of the advantages of our system is that it's electronically fuel injected, which means that the engine is tuned automatically depending on what weather conditions you're in, or what the pressure is, or what the altitude is. So that differentiates it from a lot of carbureted systems where you have to actually go out there and adjust a needle and kind of guess about the tuning of the aircraft. It makes the operation and maintenance of the vehicle pretty simple. And we've spent a lot of time trying to make this vehicle pretty much outside of the sound as indistinguishable from an electric multi-rotor as possible. So everything from the takeoff, starting of the engine, and the landing, we tried to make that pretty much identical to an electric-powered multi-rotor.
Just real quickly, I just want to thank our colleagues here at Skyfront for giving us the opportunity to participate today with them. We really enjoyed the opportunity to test out our products on such an amazing platform. The new product that you're seeing today is our Explorer. It was just announced today, so this is the sneak peek. This is our first entry into products that bridge between the UAV world and the manned acquisition side of things. So we'll have this data set available in the booth. Maybe not tonight at the mixer, but for sure by tomorrow morning we'll be able to display this and many other data sets. So please come by and take a look at it. And thanks again, Troy.
All right, so that's it's a pretty boring mission. So I'm going to bring it back now, and I'm going to spiral down, and then we'll land the vehicle. And then it's going to enter into a cooling sequence as the propellers spin down. So thank you, everybody. That concludes the demonstration. We're going to have our own tent over there, so I believe there's some time, about 10:30. If you guys want to ask us any questions, see us in the brochures. We're happy to do that for you. So yeah, thank you guys so much for your time.
Just out of curiosity, for my own benefit, who in this group is already using LiDAR systems in your workflow? Quite a few of you, right? Just then by way of poll, who's using a DJI L1 based LiDAR system? 1, 2, 3, 5. All right, got quite a few. Anybody using the micro drones LiDAR system?
Yeah.
One of you. All right. Who's using one of the older Leica systems? Anybody? Okay. All right. Yellow scan, one we just saw.
Yeah.
I think Cliff's in the crowd somewhere. All right, got 3 yellow scan users. If you haven't experienced LiDAR, I highly recommend you take the time to look at LiDAR and see what it is. I'll walk down here so that you aren't quite looking into the sun. How's that? For those of you who have not worked with LiDAR can give you greater detail and precision than photogrammetry can at a fraction of the time that it takes to process your files. So you might want to just check out how LiDAR works. I'll tell you, if you stop by the Sundance Media Group booth, we will have LiDAR scans from DJI L1 and scans from the Microdrones HR1000 system, and they'll be processed inside that trailer. So you'll see that mobile command center on the show floor, booth 214. So you're welcome to stop by and see how it works. We've got a LiDAR precision expert or subject matter expert, guru, whatever you want to call him. Brian Worthen is going to be in there showing folks how to do cross sections and how to work with LiDAR data, how to clean it up, make sure noise floor is minimized and so forth. So all that will be taking place in the SMG trailer. Additionally, you'll be able to see that same data put into Leica Infinity, Leica Cyclone, and Pix4D. So you'll be able to make some comparisons about the different software outputs and how those different software outputs function and look. So how we doing, Jason and team? I haven't seen the big monster come out yet. Okay, a couple more minutes. All right. So in addition to some of what you just saw here, you'll be able to see these outputs as well. I think we might be able to even get Troy to let us have access to this data set. But we'll also be showing some photogrammetry outputs. At Sundance Media Group, we don't sell product at all. We're not involved in any kind of hardware, software sales program at all. So you're welcome to come by with no dog in the hunt. You won't be sold anything. See how all these different programs output and how they can benefit you and your workflow. One of the things that we're seeing really happen in a big way across the industry is departments of transportation are using LiDAR for corridor scans combined with photogrammetry or colorized, what's called a colorized LiDAR scan. And this allows them to get very precise measurements of roadways and so forth. Now, is anyone here, do we have any LSITs or PLSs or engineers in training or civil engineers, civil folks? Wow, a lot more than I expected. That's great. Hopefully, if you're not flying drones, you'll be able to see during this day today and through the next couple of days how you can incorporate unmanned aircraft into your workload. We're seeing some incredible precision and accuracy that are coming out of drones combined with base stations, combined with N-trip systems. And so we're doing some really amazing things these days with aircraft. On the RTK side, for small aircraft, we've got things like the Phantom 4 RTK, which is a really popular, common RTK system. Roland, Roman, there you go. We have Autel, who's got their new RTK system that comes in for around $4,000. And base stations are available at all kinds of price ranges, starting at about $2,200, working up to about $22,000. So if you want to spend a bit of money, you can do that. If you want to be on the more budget side, you can do that. It is definitely warm. But for those of you that were here 3 years ago, remember it was just the opposite. We were freezing out here, temperature of about 45 degrees. It was really, really cold that morning. So I guess I'd rather have the heat than have the cold. All right, looks like Commaris is just about ready to set this up. Now, as soon as you are ready to take over the announcement, where's our Commaris MC? Oh, you got your mic? Is it on? There you go. All right, it's all yours, ladies and gentlemen. Next presentation is from Commaris, and they're going to start sending their aircraft out right here while their narrator helps you understand what's up.
Hi, good morning. Commaris is excited to present for you today. Seeker is a cutting-edge electronic vertical and takeoff landing system that's been purpose-built
for multiple long endurance, long range commercial applications. Seeker is comprised of 7 lightweight, rugged components making for easy field assembly. With a wingspan of 15 feet, Seeker's large airframe carries a set of modular payloads of up to 10 pounds and winds at up to 35 miles per hour. Commaris has created a compact, easy to assemble, modular design capable of rapid deployment. Even with a large airframe, the system has a small footprint for confined staging and takeoff and landing areas. Seeker can be assembled by a single crew member, or a well-trained team can assemble Seeker in under 3 minutes. Commaris has created Seeker's vertical takeoff and land design allows for takeoffs in tight areas where other fixed wing, catapult, or runway launched UAS cannot perform. It also reduces the setup process and stress on the airframe since there is no net catching or belly landings. Automatic flight controls guided by the onboard GPS allows for precision takeoff and landings every time. Many UAS specs are touted based on testing in optimum conditions, sea level, no wind, low temperatures to achieve their endurance numbers. Commaris has tested Seeker in extreme temperatures of over 115 degrees and density altitudes above 8,000 feet, and still achieves an average flight time of between 2.5 to 3 hours. Being designed for commercial inspection operations in all environments, from rural to urban, Seeker has been designed with safety as a #1 priority. It has multiple redundant safety systems, including GPS, power systems, and even 2 sets of flight control services with the ability to operate independently in the case of servo failure. Those who performed inspection work know the public and landowners do not like noise. Seeker utilizes large prop and lower KV motor speeds to reduce noise at ground when in level flight. When level at between 150 and 400 feet, the noise level of Seeker is between 40 and 50 decibels, which is quieter than average city background noise or standard conversational levels, which are about 60 decibels. Currently, Seeker is at 150 feet and is nearly silent. We will now climb to 400 feet so you can hear and see the difference. At 400 feet, Seeker is averaging 40 decibels at the ground level, which is the same noise level as your average neighborhood library. Seeker just flew overhead. Now we're going to offset our flight path so you can hear and see Seeker at distance. Seeker is going to a loader point roughly 3,000 feet away. If you direct your attention to the screen, we are displaying Seeker's optical zoom EO camera. As you can see, Seeker is ideal for detecting changes, anomalies, and intrusions found along right-of-ways and construction projects. Seeker is able to determine exact GPS location of cameras targets on the ground, so anomalies could be called in real time with precision location for teams to respond. All images are geo-tagged, making report writing faster, more accurate, and easier to generate. With cutting-edge high-voltage batteries, each LiPo cell is able to achieve a maximum charge of 4.35 volts. This extra voltage multiplied over our dual 12-cell, 28,000 milliamp batteries, along with an advanced airfoil body design, can achieve over 3 hours of flight time and reach speeds above 60 miles an hour. That's over 180 miles of distance covered on a single charge. With a slim silhouette and a quiet electric motor, Seeker is excellent for patrol or loiter security missions. You've seen it at 400 feet. Now imagine Seeker at its maximum operation altitude of above 15,000 feet. It becomes undetectable to any personnel on the ground. Combine the silhouette, noise level, and 3-hour endurance of the Seeker with its 30 times optical zoom EO and IR camera, and you get an aircraft that gives command personnel low risk and high value situational awareness for their operations. Seeker is making its way back to its original orbit, and it will be making another pass at 45 miles an hour. Seeker will now be accelerating to over 62 miles an hour for its next pass. These flight speeds combine agility and operational flexibility for rapid response, long loiter times, and effective vehicle tracking.
Over there on the berm. Wave over there, Michael, so everybody can see you. Michael was out hiking today, and his partner got heat stroke. That's Herman laying on the ground. Herman needs help. 911 call has come in. Brady, if you want to launch. Brady represents the police department or fire department within 7 miles of the location. So we're going to talk about almost a 20 square kilometer range that we can hit. He has the address. He's flying automated to the address. As the drone approaches, he's using his thermal camera to identify where they are. The thermal camera that we have actually has heat tracking, so it can pick up a body temperature. We can set the temperature that we want to pick up to alert the pilot, and then the payload can stay on the target while the pilot's paying attention to his approach. Brady has now identified Michael and Herman. Using the full-meter radar, he's going to wind up going to autonomous landing. He'll bring the drone in close, We have a special case that the AED is in. It'll approach about 5 feet. They'll drop the AED. He'll clear the airspace, and Michael will be able to apply that AED to Herman and bring Herman back to life. Now, of course, if Herman does get up and walk, that'll be a surprise to me. There the AED is releasing. Michael will wait for the drone to clear airspace. Brady, we can bring the drone back in for a landing. Michael is now going to apply the AED, and we're going to save a life. Is that cool, guys? Is that a cool announcement?
Yeah.
Cool.
I think so. I think so. And I hope more and more companies realize this. And I hope the FAA and the FDA can realize this as an important opportunity. Our industry can really make a difference. So with that being said, I would say it's pool time and cocktail time. I don't see the pool or the cocktails yet. So we're going to go ahead and land, and I'm going to pass it back over to SMG. And I really thank you for your time and appreciation. Same with all the vendors and folks here.
Thank you, Mike. Outstanding job. Look at Mach 6 coming in. Well done, Brady. There we go. All right. Okay, folks, we are at a point where we're taking a bit of a break. The next set of vendors can get set up. This is the optimal time for you to take a few minutes, go down, visit with the vendors, chat with the vendors. We're about a half hour away until our next demo. So again, please, water, drink water. We brought it for a reason. And visit the vendors, and we'll see you back in about 40 minutes.
Renee, thank you, Renee.
So you have 10 pounds to play with under that 55. So, you know, it cuts down flight time, but again, flying at 60 miles an hour, 45 miles an hour for an hour, that's a lot of ground to cover. We've had pretty good tests with this aircraft so far. Even at 45
No, we do a tremendous amount of weight.
kind of adapted standard GPS drones to kind of work in there. And sometimes you can get through factory where Right. Yeah, exactly. Yeah. So this uses a 900 megahertz system, and has the least moving parts that you can get. So no moving gimbals, everything's fixed. So that way you don't have, like I said, the forced upgrades where you can't fly. You have to go through that. You plug the battery in, it turns on, and you fly. That's it. So, and then any of the accessories, like this is the glass brake attachment. It's all Picatinny rail. So basically, if you want to add this onto it, it's good to go. Yeah, you're basically ready to go, and then just obviously pop it right off. And you can put on the LED light attachment, the robot deployment system, or the payload dropper, which doubles as the deployment system. So if you want to zip tie a pack of cigarettes, a mag, a bottle of water, yeah, you can haul it over, hit the button, and release. So if it gets flipped upside down, you can put it in turtle mode, and it'll right itself up again. If you can push, like we push hollow core doors open if they're unlatched, we can push the door open and then get in, and we can go in a hovercraft. He's like, it's too long.
Cool. Yeah, we've actually started relationships with a few companies.
What's up?
It's good.
Good. Just having a good time. Mr. Schaefer.
How you doing?
Doing great.
Repping the gym.
Always.
Cool. Been live streaming for the last hour and 40 minutes. Good job. It's some cool stuff.
Yeah, it is.
That I do something. Very impressive.
From Arizona, it's a problem.
Yeah, I mean,
We
so,
like to have 30.
yeah, that's why we are preparing those two kind of options. So battery or oh, I mean, hydrogen fuel cell itself is not the generator. It makes almost no noise. I mean, yeah. So we normally says that kind of 50% lower than that gasoline drone.
Where would I get 105? The two props on one motor. Double your money, double your flight.
Right on. Thank you, sir.
Yeah. Thank you. That looks cool demo.
This version of the drone is about $46. Now what happens when you run out of it? So it is it's half the cost of a hydrogen fuel cell over there, and you can get the gasoline anywhere. You just go to the pump. All right, so it's cool. So this is the bottom. Yes, sir. I guess. It's a servo release. Okay. Is that like a tag? Yeah. Did you guys manufacture it? We did manufacture it. Yeah. Okay. Awesome. Yeah. I did the proposal. So that sounds like a mixture of $20. That's fine.
That is $3. That was cheap.
You know, $20 is $20.
You know where I'm going to put this. That's the problem.
So where are you guys based out of, Ben? So testing operations is here in Nevada. Okay. So I'm basically the head of testing and making sure this thing does what it needs to do. Right. And then Massachusetts and Woburn, that's where our assembly and engineering team is. So we have a big facility out there that they built an airplane car. So an airplane converts into a car. That was Terrafuge's claim to fame. And so now they're marching here and saying, hey, we want you to do this stuff with the drone. And so now we've got this all going with the drone stuff, getting this ready for the U.S. market and stuff. Okay.
How many units have you sold so far?
So we are just coming to market with this, so 0 at this point. But it has been sold a lot in China.
Once again, like I said, my name is Deepu John. I'm a solutions engineer with Skydio. Before coming on with Skydio, I did 20 years in the New York City Police Department. I was in tech Nypd, and I was assigned to the tech unit. And while assigned to the tech unit in 2017, I was tasked with developing the NYPD's drone program, and launched the program. And the program very successfully is running very successfully, and I retired. And I was acting as a drone coordinator for the program until my retirement a couple of months ago. So now I work with Skydio. And Skydio is a US-based drone manufacturer. So we're a US-based drone manufacturer based out of Redwood City, California. We are a defense innovation unit, Blue UAS provider, providing secure, trusted drone solutions for the United States government. Let me move a little bit closer here. We also recently won the AUVSI Excellence in Innovation Award. Took first place in that award. And what we're going to be displaying for you today is going to be the technology that enabled us to win those awards and those accolades. So today we're going to be demonstrating the Skydio X2, which is the newest drone from the Skydio line. The Skydio X2 is purpose-built for work. The drone is purpose-built for work in defense, in public safety, and enterprise solutions, right? And you're going to see how the aircraft functions today. A little bit about the hardware. The aircraft has about a 35-minute flight time, 6-kilometer range. and it can operate. It's got 35-minute flight time, 6-kilometer range, and it's a ruggedized airframe made from carbon fiber and magnesium. All right, we're gonna get ready to go here. A little bit. So the hardware specs on the aircraft is impressive, but what's really impressive about the aircraft is the software on board, the artificial intelligence on board. There are 6 4K 200-degree field of view cameras that are on board the aircraft that provide a full 360-degree field of view of the entire aircraft's environment. And what the drone does is it takes the images from those 6 4K cameras and processes it and creates a 3D point cloud that the drone uses to see, understand, and react to the environment around it. This allows us to fly closer to objects, fly closer to obstacles without colliding with the obstacles. But I can talk to you about the tech until I'm blue in the face. But let's get right ahead with the demo. So I'm going to set the stage for you here. It's a early September morning in New York City. A drunk driver driving this pickup truck just entered the wrong way onto the FDR Drive and collided with this bus. The driver of the pickup truck is deceased, and the bus driver has serious injuries. So you, as the collision investigations unit, you have to get out there and you have to document the scene. And to make things more complicated, the United Nations building, just a few blocks up the road, is having their General Assembly, which is the largest gathering of world leaders anywhere in one place, and that's about to kick off in a few hours. So you don't have any time to document the scene and get that road cleared. If you're using a terrestrial-based scanning system, this might take you too long to document it. So you need to get this the scene documented right away, and that's where the Skydio technology comes. So Aaron, our collision investigations technician, already set up the drone. And if I could direct your attention to the screen here, I'm going to talk to you about how Aaron's going to do a 3D scan of this collision scene within minutes and have that scene well documented for investigation later on, and that road cleared as quickly as possible, so those dignitaries that are coming up that FDR Drive are not going to have to find an alternate route. Okay, so time is of the essence. What Aaron's doing right now, the aircraft is already in the air, and we're going to go through our workflow right now. So Aaron is first thing we're going to do. We're going to define a polygon, an area for the drone to scan. So first thing we're going to do is we're going to set the floor, the lowest part of the area that the drone needs to scan. So Aaron has set the floor. Next thing we're going to do is we're going to set the ceiling for the drone. So he's going to, as you can see, you'd see in augmented reality where the ceiling is, that green overlay is going to be the ceiling. Aaron's going to set the ceiling for the drone to be well clear of the height of the bus to make sure we have a good 3D capture. The ceiling has been set. We're just reducing that floor a little bit just to make sure we get all that, all the data on the ground level. And if you imagine if this not being a collision scene and it's a crime scene, there's shell casings and things like that on the ground, you want to make sure that you get all that data, and you want to get it, a complete capture. So the ceiling is being adjusted right now, and doing it through the augmented reality engine on the drone itself makes this a very effortless endeavor. So once the floor and the ceiling has been set, we're going to set the 4 pillars. We're, again, trying to define that polygon, that 3D polygon area that we want the drone to scan. So in this, 4 pillars can be set. And again, you can see that in augmented reality. You're going to see those pillars. And Aaron's going to be able to fly to the next point, set the pillar, and even if he needs to look back to reference where that first pillar was, he can turn around and you'll be able to see that set. So we got the second pillar set. Now we're going to go to the other side of the collision scene and set the last 2 pillars, and that's going to define that full 3-dimensional polygon that we're telling the aircraft to scan. All right, the 3rd pillar has been set. We're going to fly out and just do that 4th pillar right there. The 4 pillars have been set, and now the aircraft is taking a look at the area that we've defined for it. Next thing that the drone's going to ask you to do do you want to set a Geo Fence, right? Now imagine this is the FDR drive. The northbound lane is where that accident happened. I want to have that southbound lane still clear and open because I want to keep that traffic moving as much as I can. I can set a Geo Fence on this aircraft and tell the aircraft never to encroach outside of my Geo Fence. I'm telling the aircraft to conduct the scan from within the polygon that I've designed, never to go outside of it. So we're going to put that lateral Geo Fence on there for it. And the next part is going to be an augmented reality observer mode. This is really, really cool. So once you set that augmented reality observer mode, you can actually go back into that augmented reality view and know the exact position of the aircraft as it's conducting the scan, wherever it is. The AR observer mode has been set. Now the drone is pretty much doing the work on its own. It's going into an exploratory phase where it's going to look at that area that you've defined, look at the objects inside it, and it's going to try to figure out the best way to capture that scene. Aaron is not flying the drone right now. The drone is operating on its own. That exploration phase has started. Again, Aaron's got his hands off the sticks. The drone is doing the work right now. It's going to go around and look at that scene from multiple angles and figure out a few things. It's going to figure out how many pictures that it needs to take to get an accurate rendering. It's going to figure out how many minutes of flight time it needs. And it's going to tell you what the ground sampling distance is going to be. And this is key for anybody who's doing kind of crime scene and collision documentation, what that ground sampling distance is going to be on this rendering. So you already know before you get to your office and start processing these images what your projected ground sampling distance is going to be. And it's building that AR 3D mesh around your object underneath the scan. That exploration phase is just going to go on for a couple more seconds until the drone is satisfied that it has examined all the areas of that polygon that you've defined, and it knows what to do next. So we're ready now. We're ready to do the 3D capture. So right now it's going to tell you it needs 557 photos. We're going to bring down that overlap a little bit because we don't want you sitting here and watch the drone take 500 photos. That's kind of pointless. So we're bringing those side overlaps a little bit to bring this flight time down. All right, we're ready to go. We're going to tell the drone to begin the scan. Again, at this point, Aaron is not controlling this aircraft at all. The aircraft is controlling itself. His job as a pilot in command is to monitor the actions of the aircraft and it's just to make sure that it's doing what you want it to do. The 3D capture is being conducted by the drone by itself. And what you're going to see on the screen right now is that AR observer view that we talked about, right? So Aaron can look down at his screen and he knows the exact position of the drone, even if it's on the other side of the bus. Don't worry, we have Theo set up on the other side to make sure we're compliant with FAA. And Aaron can just watch the progress of the 3D scan take place. That AR observer mode, as you see that overlay, you see how that the entire scene has like a yellow overlay on it. But that's a visual cue to Aaron, letting him know that the yellow areas don't have enough data for us to create a full 3D scan. As the aircraft continues to take additional pictures, you're going to see that AR overlay go from yellow to green to purple. When we get to that purple, which is where we want to be, we have sufficient data to create an accurate 3D model of the scene. So while the drone is doing its work, and this is kind of the boring part for the pilot and me as a narrator, what I want you to do is kind of try to imagine what you can do with a Skydio and how you can put a Skydio to work for you. Obviously, we're demonstrating the public safety use case here for collision and crime scene investigations. Like we said, if we imagine that this was a scene of a shooting and there's shell casings on the ground, the aircraft can automatically document that entire scene. But say you're in a different vertical. Say you are in the energy industry and you want to operate, you want to inspect your power substation. the power grid. Because Skydio's drones operate on visual navigation, and it's primarily operating on visual navigation, it's not reliant on a compass or a GPS, a magnetometer or a GPS. So you are able to fly very close, right up to those power stations without having any kind of electromagnetic interference that's going to interfere with the drone's actions, right? I know if you are show of hands, how many of us are in the energy industry here? You know that flying close to those power stations, you have to do a pretty wide standoff, and you have to use those zoom lenses to be able to inspect your infrastructure. With Skydio, you can fly right up to it, and you can do the inspections right there. Okay, yep, we're gonna, like I said, watching this drone kind of fly around and capture 500 pictures is not very entertaining, so we're gonna do a land. And what Cabe, a part of our solutions engineering team, what Cabe is gonna do is do a hand capture of this drone. The aircraft is designed to be launched and recovered by hand, which prevents you from dropping it, putting the drone on the ground over here and pulling in all kinds of dirt and dust into your sensors and your processors and things like that. And it makes it very easy to be able to hand launch and hand capture this aircraft. And we're gonna let, I think it's gonna take a few more pictures. But again, if you're, we're talking about the power grid, the power inspection vertical. If you're in enterprise and you want to do infrastructure inspection, you can do those kinds of jobs with the Skydio much faster, much more efficiently, and much safer than you can with other aircraft in the field. Cape's doing a hand capture of the drone right now. And that's it. The entire scan, the scene has been documented. The FDR drive is back open, and all the dignitaries that go into the United Nations Assembly. Good job by the collision investigations team. And what we're going to do right now is we're going to pull up a quick rendering that we did yesterday of this area. You know how you watch the cooking shows and they show you putting the food in the oven, and 2 seconds later it comes back out fully cooked? Well, this is a rendering of the scan that we did of the same scene yesterday. And this is a quick rendering that we did just to be able to show something to you guys today. So that's the full 3D scan of that entire scene. Yep. So Kate was telling me that scene took about an hour to process. Folks, we'd love to talk to you. If you'd like to stop by our booth later on, come by, stop by. We'll talk to you about the different use cases that we've used Skydio for, and we'd like to hear about the different use cases that you're imagining using Skydio for. We'll be over here. We'll also be on the show floor tomorrow and the day after. Looking forward to meeting all of you. Once again, thank you for braving the heat, being out here. Thank you.
Outstanding. Folks from Skydio got some great technology, that's for sure. Well, coming up next, we have the folks from Autel. They're going to be showing their Dragonfish aircraft. So it looks like they're getting ready to get set up over here. You're going to put on launch pad, Alejandro, or no? Okay, good. But while we're waiting for them to get set up, I want to just call out a couple of thank yous to some folks. First of all, again, the folks at Commercial UAV, really thrilled that they are able to bring this to you. We're grateful for the opportunity at Sundance Media Group to be a part of this event with you. And this is my opportunity to point out all the folks in yellow vests that are Sundance Media Group folks. We're very grateful to them for being here, making sure we have a safe event, making sure that we have an event with all the things that you need. We are struggling a little bit with the heat and some of the electronics that we're dealing with, but it seems like it's getting us here and there okay. I want to thank the folks from the bus company and the folks from the beverages and water that are here. Please make sure that you drink, not only because you need the liquid in your body because of the desert heat, but we don't want to take it home. Help save the back of our truck so that we don't have to carry quite as much equipment or as much food home. All right, Autel, how we doing? Max, Alejandro, I'm looking for your pilot, Gary. Are you good to go, Alejandro? All right, looking for Gary. Gary and Max up here. Max, you guys ready? Do you need another minute? 1 more minute? All right, 1 more minute. Now, some of you in the past have probably seen the Dragonfish fly at previous Commercial UAV Expos. I flew it here 2 years ago, and it was flown the year before that. This is not at all the same Dragonfish that was shown to you 2 years ago or 3 years ago. It's been completely re-engineered with a bunch of payloads, and we'll leave it to the folks at Autel to share with you what they've done. But for those of you who had somebody a moment ago said, well, I saw it fly last year, completely different aircraft. The one you saw, in 2019, stripped apart, you can see it even looks quite a bit different. And so you'll be able to see how it's different and some of the new features and tools that they brought to the table. Max, you good to go?
Is the mic live?
We can hear you.
Awesome.
All right, I'm going to turn it over to Max Lee and Gary DeLuca from Autel Robotics. Take it away, guys.
Well, everyone, thank you very much for coming to this demo. I'll do some brief introductions here. So we have Gary DeLuca, the CEO for Autel Robotics US. My name is Max. I'm the general manager and part of the ownership group of Autel. And we have Alejandro. Oh, here he is. And Alejandro here will be our field assistant. He's the support manager, and he'll be our visual observer for today. Now, the Dragonfish is Autel Robotics' lightweight electronic eVTOL aircraft. That means it is a vertical takeoff and landing. The advantages of such a system is you have all the flexibility of a and that means you can up from nearly anywhere. You don't need runways, slingshots, you don't need launchers, you don't need trailer tow anything. It's a very compact and light system. As long as you can find a 10 by 10 foot square, an area of space, you can rise above all your obstacles. You can do your transition at around 200, 300 feet, and then you're off on your missions. No worries about runways, no worry about learning how to throw aircraft, and keeping things very, very simple. And simplicity is the key for the Dragonfish here. Very simple to fly, very safe. Almost no training required. The thing just basically flies itself, and we were going to demonstrate it here. So Gary here, he's got our Dragonfish controller with the screen connected on the big screen, and then we don't have to pre-make any mission plans. We can make it live. There's no need for PCs. We can just arrive on site. We'll making a mission is as easy as 1, 2, and 3, and we're just going to demonstrate that everything is ready to fly right out of the box. No more tweaking. So Gary here, he's in the mission planning phase. You see that we have 3 missions. We have the waypoint mission, the polygon, and the rectangular. The rectangle and the polygon. Gary, why don't you click in to show how easy it is? So we're going to zoom into Vegas. Here we are. We're just going to tap the screen once, and boom, you have your flight plan. The green is where the Dragonfish will fly. You can adjust the area you want to map. And Gary's going to exit. And we're going to go to our waypoint mission, which is the mission that we're going to be demonstrating today. So now we're heading to our transition altitude, 185 feet, and now it's going to do this transition, which will take around 300 feet. The main fuselage propellers shuts off, and it's very, very silent right now. The Dragonfish is basically inaudible at around 400 feet AGL, unless it is directly above you, and it's just a slight whirl of the propellers. So we'll let it do its circle up point to its mission altitude of 385 feet, and then we're just going to head over to our first waypoint. See on the screen here. So one thing about the Dragonfish is you can fly this thing completely autonomously. You can just set your waypoints. You can build it at the launch site, or you can have it pre-built in a computer and upload it to our controller. But this is not the only way to fly the Dragonfish. Let's say that you're on a mission, you're looking around, just chilling, and then you see something like a suspicious vehicle, suspicious person. You don't want the Dragonfish to just keep on flying. You want this flight path to be dynamic. You want to change the Dragonfish, and let it fly to suit your need. So let's say that we want to be somewhere else, Gary. Can you set us a quick mission, super fast? So Gary's going to click the quick mission button. We're going to plop a point down on the map, and we're going to set our altitude and what the orbit radius. And so what you see here is the Dragonfish has now deviated away from its pre-coordinated flight path and is going off to this point that we have just plotted out. So the Dragonfish deviates. You can see the little airplane symbol is going to the green circle that we just set. Gary, why don't you tap the screen to stabilize our gimbal? That works. Gary, disengage, return to home. It seems like we may have flown out of the area that we're supposed to, but that's fine. Gary, can you switch back to camera view and we can show some of the dynamic track capabilities of the fish before Chloe returns home. So while Gary's manning the camera, I want to mention a few more things about the Dragonfish. Is that during any point while it is flying, if you want to fly it manually, you can. All you have to do is to swap the button, flick it from automatic to manual, and then the Dragonfish will fly like any normal quadcopter. If it is flying slow, it will become a quadcopter. If you speed it up fast enough, it will automatically transition to a fixed. It is not possible to stall this aircraft. You can do whatever the heck you want with it, and it is super easy to fly. You can throw the sticks like you would with any Evo or DJI or Skadio. Just go crazy at it, and it won't fall out of the sky. Not recommended, but that's just this additional safety feature. If you see if you need to brake, the Dragonfish can brake in under 90 feet, then it would just hover. So here right now is using our dynamic track on the screen. You can see that there are little bullets that's popping out in and out of view. So this is one of our AI recognition technology. And what it is the Dragonfish is actively recognizing those objects as something from surrounding. So what I mean is the Dragonfish can recognize people, it can recognize horses, trucks, cars, and watercraft, and also people on bikes. So this makes the tracking particularly strong. Okay, why don't we target something at fun? There's also another way to track the objects, so you can draw a box around a particular structure. And the Dragonfish will deviate from its flight path, and it will follow, in circles around that structure. If that, structure is an object that happens to be moving, then the Dragonfish will move with the subject. You can go up to about 62 miles an hour. With the, Dragonfish's minimum cruising speed is about 38 miles an hour. Is it possible to switch over to the camera view and zoom in and show us the beautiful zoom capabilities? So the current Dragonfish that we have is the triple sensor Dragonfish. That means it has a payload of 3 sensors. You have a 4K wide angle for your situational awareness, and then you have a 20 times optical zoom with 240 times digital zoom. And then you have a thermal 640 by 512 radiometric sensor at 30 frames per second. it appears that Gary is on manual mode. So he braked. You know, the Dragonfish is now just hovering like a regular quadcopter. All right, Gary has initiated go home, so now the Dragonfish will automatically come back, transition, and land. Please give us a moment. The Dragonfish is doing the circle down point to go from 385 to 185 AGL, and it's going to come in for the transition and landing. And again, I want to make a note on Dragonfish's precision accurate landing. We should be around half an inch to an inch away from where we take him out without any pilot input.
Thank you, Adrian. Yes, it is. Very amazing.
So we still have around 2 minutes and 30 seconds. So Gary is going to prep up for another flight. We're going to take it off into the air and play around with the dynamic track to show you the capabilities of the camera and the track features.
We'll give you 5 minutes, Max. Go ahead and take a couple extra. People want to see this. So go ahead and make it happen. Guys from BRINC, please be getting set up. You're up next.
now we're at mission altitude, 285 HL, and then here is going to look around to see if there's anything interesting to track. You can orient the camera in many ways. There are two scroll wheels on the controller. One controls the up and down, and then the other one the left and right. But my preferred method of controlling the gimbal is simply by tapping the screen. If you tap right, the gimbal will turn right. If you tap left, the gimbal will turn left. And it will stabilize itself. So here you just drew a box around the road. So now the Dragonfish has deviated away from the flight path and is now fixated on that vehicle right here. Dragonfish's tracking is visual based, so sometimes the object needs to be large enough for it to recognize it as something distinct. So if we're at 3 times zoom, we're going to zoom in a bit more, preferably. If you are zoomed too close into the vehicle, the Dragonfish no longer recognizes it as a vehicle. So it will lose the track. So you don't want to be too close. The proper method of doing tracking is you want to have a point, stabilize your camera, zoom in to about 5 times zoom. So the Dragonfish recognizes the vehicle, and then you zoom in a bit more. You reacquire the target, and then you in a bit more. You reacquire the target, and then you might see the license plate, and then you tap on the license plate, and then it will get to the license plate info. All right, we're heading back down.
BRINC team, you guys want to get ready to go? You're up next. BRINC. Well done, Dragonfish. Right, the top down on the landing pad as it should be. Thank you, Max. Thank you, Gary. Thank you, Autel Robotics. Great job. Just a second or two for BRINC to get set up. I won't affect their demo. I'll just say that there's a reason they're putting some glass up here in the window. I think you're going to see something pretty exciting here. We're just about out, folks. We got the BRINC truck bolt coming up here. Now, it would be inappropriate for me to say too much about some of the different manufacturers, but we're kind of proud of BRINC because they are a local Las Vegas company. So the aircraft that they're flying are made right here in Las Vegas, 100% of it. So I think you're going to be really impressed with what they're doing. And they've got this truck vault system for rapid deployment, so forth. Las Vegas Metro is using some of these devices. They're heavily used in SWAT situations where the aircraft has to fly into a home. And I'm sure that BRINC's announcer will tell you a little bit more about what's going on there. So we're going to give them just a couple of minutes to get this glass set up. And once they have that in place, we'll see BRINC. I think they're going to deploy off the truck vault, or we move the landing pad. You can move that up? Outstanding. Now this will be our last demonstration for the afternoon, so if you're looking to grab another bottle of water or a can of soda or some of the snacks that are back there, this is your opportunity. It looks like we're probably roughly 5 minutes out until BRINC's ready to go. Is that right? About 5? 3? Oh, 3 minutes. So 3 to 5 minutes, we'll be ready to go. So grab yourself another bottle of water. Folks, I can't iterate this enough. Even if you just had a bottle of water a few minutes ago, please grab another bottle. We have had one attendee suffering from heat stroke this morning. So please drink water or other liquids to keep your body going in this desert, even if you're just sitting and non-active. So with this, I'm going to turn you right over to Angad from BRINC. So Angad will be taking you through what BRINC is doing their demo. Here you go.
All right. Thank you, Douglas. I really appreciate it, sir. Hey, my name is Angad Singh. I'm the Director of Business Development for BRINC Drones. We are a Las Vegas company, so welcome to Las Vegas. Well, technically we're in Henderson, but regardless, we appreciate you guys coming out. BRINC's a little unique. We are making all of our drones here in Las Vegas with American labor. So it is 100% end-to-end manufactured here in Las Vegas, Nevada with American labor. And we design our drones specifically for law enforcement and DoD applications. We essentially provide the premier indoor solution for drones that exists on the market today.
Firmware upgrades or anything that's going to ground you. So when those seconds count to get this thing going, literally from start to finish, we can have the drone up and ready operational in about 45 seconds to a minute. Analog transmission, so it has a better penetration rate when you're trying to get into buildings and navigate your way through it. If you hit a hollow core door that's unlatched, you can push your way through it, kind of hovercraft into a room, go look underneath the bed or in an attic space and around ductwork, just kind of flying around and then pushing it and then starting two-way comms. So you find the person of interest in a house or a building and you want to start that de-escalation process, kind of talking to them, we can call the drone. After about 2 rings, it picks up and you have full two-way communication. So we'll start in turtle mode here where we can flip the drone upright just to kind of show you in the event that the drone hit a wall or hit some angle or something and got itself knocked over, you can reverse the motors and get the drone back upright again and then continue on with your mission. So. The drone, unlike GPS-based drones, you can fly either completely manual or with a LiDAR-based vision system. So inside homes, if you need help kind of navigating upstairs or around some unique corners, that system can assist the pilot in doing that. Otherwise, you have full, complete manual control. So whether you want to hover at within inches above the ground or go up to a higher altitude, you have full ability to do whatever you need to do for that. So. Chase is going to be adding on the glass breaker. So when you'll enter the bus in through one window and come back out, and then our makeshift little house there, you'll see that piece of glass on the front. We'll use the glass breaker to puncture and basically drive right through that piece of glass and continue on the mission. So just to kind of simulate what you would have if you were on a high-risk situation in a house. This is the new Lemur S, and it now features the ability to use a smart controller, which has a built-in screen, or just see Chase using today the FPV goggles. So if you wanted to have a co-pilot situation where the pilot used the smart controller and a co-pilot used the goggles just as a vision, you can add that option built in.
you'll be engaging the glass breaker. Pretty amazing capability for that size of drone, and the ability to attach multiple other options. So if you wanted to have multiple of these drones flying all at the same time, you could have one do your breach as this just did, and another one come in. We have lighting attachments, payload droppers. We've actually launched this drone with our terrestrial landing pad or landing option, where we've launched it from Spot, the Boston Dynamics dog. We'll remove the glass breaker just for the other portions you'll be able to see a little bit easier. When Chase enters the bus, we'll flip it into night vision mode. The camera has a fully selectable on-the-fly day and night vision optic, and it's also easily replaceable, which is the cool thing about this system. So if you break props, break prop guards, anything pretty much outside the fuselage, it gives you field repairability. So you don't have to worry about sending it back into the manufacturer necessarily. Most of the stuff that you're going to see go wrong with this, you can replace right in the field, which comes with the training that you get when you buy this system. Perfect for confined space, and obviously a multitude of different platforms or areas that you can fly this system into. Obviously, see being able to navigate through that bus between seats, in and out of small windows. This thing can handle just about anything you throw at it. You have to bump your way around corners because obviously most of the time, if not all the time, you're going to be in environments in which you know nothing of what you're navigating through. So unlike other drones, even with prop guards on them, you'd be highly unlikely to be able to navigate, if not at all, most likely in this type of environment. The night vision, yeah, it's not obviously going to show you too much with the night vision side of things right now, just because there's so much daylight, but it is obviously have the ability to see incomplete darkness, and we have the LED lighting attachment that you can add on as an accessory to help amplify that even more.
That's cool.
Total flight time of this system is about 26 to 28 minutes with up to a 10-hour perch mode. So if you found the person of interest inside a structure and you wanted to sit and try and talk the situation down or de-escalate it, you call the phone, set up that communication, and you can sit there for hours on end having that two-way. So the de-escalation process, mitigating that human risk factor, not putting in SWAT teams or patrol officers in the line lane to a situation that might end up deadly or costly to them. And that is it.
Awesome. It's the BRINC lemur. It's the BRINC. It's the lemur.
So we'll show just a little bit wrapped around how rugged this system is. We can kind of bump it and bruise it into walls. I've a number of times have broken glass to the point where it's shattered, or spider web cracked out but not completely shattered. Where I've been able to drive the drone in as a battering ram and keep pushing through it without any issues. Letting the thing free fall from several feet in the air. This uses a lithium-ion battery instead of a LiPo battery, so a little more rugged and built specifically for that type of system. With Datorama, we offer on-site training of this system. So if you were to buy one of these, we offer end-to-end solutions, whether it's the truck vault system you see over there, which we can build you something as basic as just a box and storage system, to having power inversion and remote viewing capabilities. such as what the BRINC has. It has a transmitter box. It's got a magnet on the back of it. So you could take that box, stick it to the side of a Bearcat SWAT truck, and remote live stream that feed right to a command center, pretty much anywhere within 6 to 8 miles. So